All right. In this one, what we're going to do is we're going to look at graphing transformations of the quadratic parent function. So remember that our parent function was just x squared. So what we're going to do is look at how this other stuff in here, so this plus 1, the negative sign, and this minus 2 here, will affect the parabola, basically how it's going to affect the graph that we've already seen. Whenever I approach one of these problems, I do it very systematically. I go through each step and see what it's going to do to my graph. First thing I look at is the sign in the front of my graph. So whatever is multiplied in front of this parentheses. In this case, it's a negative sign. Now, since it's a negative sign, it means that my graph of my parabola is going to be reflected across the x-axis. So that means that normally it looks like this, right? That's what x squared looks like. But this negative tells us that instead my parabola will be upside down like this. Oops. The next thing that I look at is the plus 1 inside of here. This plus 1 and this minus 2 will tell me where my vertex is going to be. Now remember that the vertex is that lowest or highest point. In this case, since our graph is upside down or reflected, it means that our vertex is going to be the highest point on our graph. So first we look at the part inside of the parentheses. Any number added or subtracted inside of the parentheses is going to move our parabola left or right. Now it's a little bit annoying because the sign here actually tells us the opposite of the direction that we're going to move our parabola. If it's a plus here, it means that we're going to move to the right. So here we've got plus 1, and that tells us that we're going to move left 1. Okay, so the opposite of what we would think. Usually plus means right, but inside of a parentheses we do the opposite. So since it's a plus here, we move left 1. Now we don't want to plot that yet because we've got to look and see if it's going to move up or down. That's where this part out here comes in. Since we have a negative 2, that tells us that we are going to move up or down. Now when we're inside the parentheses, we do the opposite of the sign. When we're outside of the parentheses, we do whatever the sign tells us to do. So in this case, since it's a negative 2, we will move down 2. Now when I say move down 2, I mean that the whole graph is shifted down 2. It's usually easiest to start with our vertex and then plot some other points after that. So that's what I'm going to do. I'm going to move my vertex left 1 and down 2. So my increments on this graph are by 2. That means 1 is about right here. So I'm going to go 1 and down 2 and make my point. Now I need to decide where to put my next 2 points. Remember that a parabola has to have at least 3 points in order to be described, unlike a line which only needs 2. So I need to figure out a point that's over here and a point that's over here. The way that I do that is I look at the number that's in front of my parentheses. That number in our vertex form, which looks like this, f of x equals a x minus h squared plus k, tells us essentially the parabola version of slope. Okay, this a out in front is going to tell me how far down I need to move after I've moved 1 over. Since a is 1 in this problem, anytime you don't see a number, it means it's 1. And so since a is 1 here, that means that we will move 1 to the right and down 1. Now if that number were 2, we would have moved down 2. One nice thing about parabolas is that they're symmetric, which means that there's basically a line that we can draw down the middle, and the 2 sides of it will look like mirror images. So if we know what one side of our parabola looks like, we automatically know what the other side looks like. That means that I can go ahead and put a point right here also. Now all I have to do is sort of sketch out my graph here. I have 3 points, and that's all I need for my parabola. So it's got to go through these, and it has to go through these. So those are the steps to go through whenever you're graphing a parabolic transformation. In the next video, we'll look at how to go from the graph to writing down the function. We go through the same steps, but the process looks a little bit different in reverse.